서울대학교 사범대학 제4회 초청강연을 시작하도록 하겠습니다. 오늘 사범대학뿐만 아니라 여러 단과대학 선생님들께서 많이 참석을 해주셨고 학내외에 관심이 많은 걸로 알고 있습니다. 우리 홍기현 전 교육부총장님도 와주셨고 또 온라인으로 보니까 우리 여정선 교육부총장님도 들어와 계신 것 같습니다. 저희가 사실 교육의 대전환기를 맞아 굉장히 중요한 분기점에 서 있다고 생각합니다. 저희가 맞이하고 있는 이 도전은 단순히 이 인공지능을 기존 교육에 접목하는 차원을 넘어서 과거에 이렇게 표준화된 대량 교육 시스템에서 이제 학생들의 특성을 다 고려한 개인 맞춤형 학습 시스템으로 이렇게 전환해야 될 그런 시점에 있다고 판단이 됩니다. 우리 오늘 모신 커슬린 교수님께서는 오랫동안 이 학습과학을 연구해 오신 이분의 권위자십니다. UCLA에서 학부를 졸업하시고 스탠포드에서 인지과학으로 박사학위를 취득하셨습니다. 그리고 하버드대학에서 32년간 심리학과에서 교육과 연구를 하셨고요. 거기서 심리학과 학과장 또 사회과학부 학장을 역임하셨습니다. 그 이후에는 스탠포드 대학으로 옮기셔서 행동과학 연구센터장을 맡으셔서 3년간 봉사를 하셨고요. 그 즈음에 미네르바 프로젝트를 시작하게 됩니다. 벤 넬슨이라고 하는 교육에 관심 있는 사업가가 미국 고등교육에 대한 근본적인 이 문제의식을 가지고 새로운 교육 모델을 만들어야 되겠다는 그런 질문을 던졌는데 거기에 대한 솔루션을 제공하신 분이 우리 스테판 커슬린 박사이십니다. 이분이 그동안 연구해 오신 The Science of Active Learning, 학습과학인데요. 능동적 학습과학이라는 원리를 기반으로 기존의 교수자 중심에서 지식을 주입하는 방식에서 학습자들이 학습을 하는 현상의 원리를 바탕으로 해서 보다 효과 있는 그런 학습 시스템을 만든 것입니다. 우리가 흔히 알고 있는 미네르바대학 하면은 온라인으로 수업이 이루어진다든가 아니면 7개국을 다니면서 팀 프로젝트를 한다든가 라는 것으로 그것을 그 혁신의 핵심으로 알고 있습니다만 사실은 미네르바 유니버시티 그 교육 프로그램의 진정한 그 혁신의 핵심은 바로 티칭에서 러닝으로 포커스를 옮겼다는 것입니다. 그리고 그것이 저도 미래 교육이 지향해야 될 그런 지점이라고 생각돼서 오늘 커슬린 박사님께서 마침 한국을 방문하신 기회에 이 자리에 이렇게 모실 수 있게 되었습니다. 커슬린 박사님은 심리학자이시면서 이제 Cognitive Science, 인지과학을 하셨고요. 그리고 학습과학의 대가로 이렇게 인정을 받으셨습니다. 미국 국립과학원 학술상도 수상하셨고 14편의 저서와 350개 이상의 논문을 왕성하게 발표를 해오셨습니다. 지금도 이 하버드대학에서 은퇴를 하셨지만 명예교수로 계시고요. 현재는 Active Learning Science 주식회사의 창업자이며 파운더리 칼리지의 최고 학술 책임자입니다. CAO라고 합니다. 우리한테는 좀 이렇게 낯설은 용어이죠. Chief Academic Officer라는 그런 개념인데 그것으로 그런 포지션을 가지고 이 대학의 교육 시스템을 설계하고 그 설계를 바탕으로 학교를 운영하는 그런 설계자라고 보시면 되겠습니다. 자, 우리 뜨거운 박수로 커슬린 박사를 환영해 주시면 감사하겠습니다.
Hello, everyone. Thank you for coming and for hearing this talk about the science of active learning. Okay, so this presentation is going to have four parts. The first is what is active learning? Three parts. Why is active learning effective? And how can we use the science of learning, of active learning? And I'll talk about 5 principles. So most of the time, I'm going to focus on these 5 principles that have come out of the science of learning. So the first question is, what is active learning? The way I use the term, active learning is using information or skills in the service of achieving a learning objective. So using information or skills with a goal of achieving a particular objective about what the student should learn. So I use the term as learning by using, not learning by doing. So learning by doing, just an unstructured discussion or exploration, that's not good active learning. You need to have a goal. So active learning depends on specifying clear learning objectives. So learning by using, active learning as a goal. So let's pause for a second and maybe be clear about what I mean by learning objective. So it's not a topic. It's observable and measurable. It's specific and active. So here's a poor example. So understand DNA and RNA. So it's not as bad as it could be because it's not a topic, just RNA and DNA, that would be a topic. With a verb, understand, it's better. But it's not really observable. How do you observe if someone has really understood something? There are different levels of understanding. It's hard to measure. It's not very specific, and it's not active. A much better example would be describe, that's a good verb, I can measure that, the chemical and structural characteristics of DNA and RNA. Very specific and easy, action-oriented, easy to measure. So learning objectives are critical for active learning. Learning by using requires goal-directed lessons. I'll give you some examples as we go along. So active learning, why do we care about active learning? Why am I talking to you about active learning? Active learning is more effective than traditional lectures. It's more effective. Don't take my word for it. There have been many, many studies of this now. So here's the classic initial meta-analysis of 225 studies comparing lecturing to active learning. Let me just read this to you, this one section. The studies analyzed here document that active learning leads to increases in examination performance that would raise average grades by half a letter, and that failure rates under traditional lecturing increased by 55% over the rates observed under active learning. Finally, the data suggests that STEM, that is science, technology, engineering, and math, instructors may begin to question the continued use of traditional lecturing in everyday practice, especially in light of recent work indicating that active learning confers disproportionate benefits for STEM students from disadvantaged backgrounds and for female students in male-dominated fields. This result has been backed up in several additional meta-analyses. It's not just for STEM, it's actually quite a general result. Active learning is more effective than traditional lectures. Why? Why is active learning effective? Because of how the brain works. The science of learning, so here's a definition I found. The science of learning draws on research from cognitive psychology, neuroscience, and education to understand the processes through which we learn. The title of this talk was The Sciences of Learning, because actually there are multiple different sciences. Also data science contributes. There are various other sources of insight, ranging from anthropology and even linguistics. So the critical thing is, it's about using research results to understand learning and memory. So learning and memory are different sides of the same coin. You can't have learning unless you have memory. There's no memory, you didn't really learn it. And you can't have memory unless there was learning, because unless you got it in, there's nothing there. So they're different sides of the same coin. It's the science of learning. An enormous amount is now known about how learning and memory work. So I'm going to use the term learning to correspond to encoding, which is taking information in, so organizing it, taking it in through the senses, hearing or seeing, and storage, which is integrating information into what you already know. Memory consists of retention, preserving information over time, and retrieval, digging it out, getting the information when you need it. Huge amount is now known about learning and memory. Thousands and thousands of studies. But very little of that information is systematically used in education. Very little of it. So I'm going to tell you about 5 principles that I have formulated. I've not read the entire literature. I don't think anyone alive has. But I've written several textbooks that have forced me to read relatively widely. So I have tried to organize what is in the literature into 5 principles. The principles are based on large literatures. They capture highly replicable phenomena. Not just one study, not just 2 or 3 studies, many studies. Large effect sizes. They move the needle. These phenomena matter. They actually make a real observable difference on learning. And they're very general. They can help humans learn anything. So these were the criteria, the principles that I used for organizing what I'm about to talk about. So there's 2 groups of principles from the science of learning. 2 big groups, 3 in the first, 2 in the second. First big group is pay attention and think it through. So I'm going to give you 3 particular examples of principles that all are about paying attention and thinking it through. And then we'll talk about creating appropriate mental connections. So let's start with the first. So the 3 principles are deep processing, deliberate practice, dual coding. So let's go through them one at a time. Deep processing. Now, one of the things we know from active learning is if people passively sit and listen like you've been doing, you're not going to learn very much. Surprising how little you're going to learn. We need to get you actively engaged. So let me practice what I'm preaching and get you actively engaged with a demonstration. So we're going to have several demos in this talk. Okay, here's what we're going to do. You will soon see a list of words. Each word has living in green or height in blue in parentheses right before it. If you see living, please decide whether the word right next to it names a living thing. So for example, if you saw tree, you would say yes, because tree is living. If you saw rock, you would say no, because rock is not living. Is everybody clear on what this is? Judge living, non-living. The second judgment, if you see height, please decide whether the word has a taller letter, that is a higher ascender, at the beginning than at the end. So look at the way that word house is printed. See, house, the H rises above the E. So this is taller than that. But look at these words. Mouse, the M is not taller. It's the same height. And here, most, the M is actually lower than T. So these are no. Okay? Very simple. So be clear. Let's go through these examples. All right, how about living lizard? Tell me, yes or no? All right, what about height? Okay, how about height dog? Yes, okay, living brick. Excellent, very good, very good, okay. Yes, so you've got them all right. That's very good. All right, so please make the indicated judgment for each word in the following list. Do this silently. Don't write anything down. Okay, you ready? Could you please raise your hand when you're done with the entire list so I can see when the room is finished? Thank you. Okay. All right. Now, please recall as many words as you can. They're on the list. You can write them down now if you want. I'm going to give you 15 seconds. Okay. Okay. Now, look at the words again and count how many words you correctly recalled following each type of judgment. This is the honor system. You're not being graded. Just do a fair score yourself. So how many of the words under the living column did you remember? And how many under the higher column did you remember? Okay. Now, finally, please notice whether you recalled more words that you had judged in terms of living, non-living, or more words that you had judged in terms of relative height of the first letter. Okay, so can you raise your hand if you recalled more words following the living, non-living judgment than the height judgment? Can you please raise your hands? Raise them high. I want to see them. Look around the room, everybody. Okay, now raise your hand if you recalled more following the height judgment than the living judgment. Look around. This is a big effect. This is a big effect. So typical result, what you saw here, most people recall more words that they had judged in terms of living, non-living, than they had judged in terms of higher, not higher. Why? Why? Judging whether a word names a living thing requires more mental processing than judging surface properties. To decide whether it's living, you've got to think about whether it moves, it's got hair maybe, whether it's a plant. You have to go into memory and find characteristics. Whereas to judge height, you just look at what's presented to you on the surface, much less processing. The principle of deep processing is the more mental processing one performs on information, the more likely one is to retain it. This is true whether or not you want to retain it. So think about this. At the end of the day, you're laying in bed at the end of the day. Can you recall the events of the day, things that happened during the day? Here's the question. How much of what you recall did you intentionally try to memorize at the time it occurred? So how much what you remember at the end of the day, what you remember at the time it happened, did you say, I want to memorize this? Okay, could you raise your hand if 50% or more of what you recall at the end of the day you intentionally tried to memorize? Nobody. Could you raise your hand 25% or more? Nobody. Okay, 15% or more. 10% or more. 5%. Okay, excellent. The modal amount, I've done this many times now, the modal amount is somewhere between 5 and 10%. So think about this. Between 90 and 95% of what you remember at the end of the day when you're in bed thinking, you did not try to memorize when it was happening. That's called incidental memory. The vast majority of what is remembered is a byproduct of paying attention and thinking through the information or event. Fundamental fact. How is this relevant to teaching and learning? Focused deep processing. Active learning exercises should direct learners to focus on what they need to know to achieve learning objectives. Let me give you an example. I'll give you an example of active learning that uses focused deep processing. So it's going to be a debate. So a debate is a technique you can use to induce deep processing of material that underlies the learning objective. So you have to decide what you want them to learn. You need to know that in advance. That's the learning objective. Remember, that's the critical thing. And then what you do is you design an activity to help them process deeply the information they need to know to achieve that learning objective. So here's an example. Example learning objective. Identify trade-offs between living on a farm versus living in a city. So say it's a sociology course, and you want them to understand the implications of the Great Migration to cities. So what were the trade-offs between living on a farm versus living in a city? So here's what you can do. You can use what's called the jigsaw design. So the proposition for debate that's going to come up is it is better to live on a farm than in a city. That's the proposition. So phase one, 4-person breakout groups. So you can do this in Zoom with 4 people in a room, or you can do it in person. 4-person breakout groups prepare to debate. There are 2 types of groups. One type prepares to argue for pro. That is, it is better to live on a farm than a city. And one type prepares to argue for con. Now, they know that they're going to be having to argue that position later themselves. Phase 2, you now break up those groups. So there were 4 people in the first groups. After 10 minutes, you create new 4-person groups that include 2 representatives from the pro groups and 2 from the con groups. This is why it's called jigsaw. We took originally homogeneous groups of 4, we broke them up and reassembled them, and put them together again. So they now debate, and they note the strongest and weakest arguments on the other side. You can see what's going on here, if you pay attention. Then finally, they come back to the class as a whole, and each person summarizes the strongest and weakest arguments made by the other side. So what we're doing is we're using incentives and consequences to lead learners to engage in deep processing. So look at this again. In that first phase, they know the second phase is coming. So we're incentivizing them to pay attention to the arguments for pro or for con, whatever their group was, because they're not going to want to be embarrassed in that second group. Social embarrassment, very powerful. So they'll be incentivized to do well and do their part for the team, their other partner, for that second phase. And then the second phase, they have to write down the strongest and weakest arguments. Why? Because they know there's going to be a debrief at the end where they may get called on. So you've used incentives and consequences to lead them to focus and process deeply the information that underlies the learning objective. So preparing for and conducting a debate induces deep processing material, helps learners achieve learning objective. So that's the first of these principles, deep processing. Second, deliberate practice. Learning is enhanced by using feedback to focus on practicing the most challenging aspects of a task. So it's not just doing it over and over again. It's not just practice. It's deliberate practice. So the key idea is identify what aspects of a task are most difficult for you and work on improving those aspects. Typical examples, learning language with a tutor. So I taught in France for a year. I'm terrible with languages. So I hired a tutor, and I would say a word in French. She would say it back correctly, emphasizing, say, the sound of the R or the vowel. And I would listen very carefully, try to correct, say it again. So I would focus on the particular problem I was having. Apprentice craft person. You want to become a plumber or electrician. You apprentice with someone else who teaches you. Or working with a golf coach or any kind of sports coach. Coach will see you do the swing and notice that you're not leaning properly or something and focus you on that. Or playing piano. Anyone here a musician? Anyone here a musician? No. Okay, sorry, well, my wife and I are. And when you learn a piece, you go through it and you see where the hardest parts are, and you spend more time at those because the rest of it is pretty easy. This is all examples of deliberate practice where you identify the hard parts, typically via feedback from somebody else, or you can give it to yourself, and then focus on that. Here's the problem, challenge, using deliberate practice at scale. So the examples I gave you all involved one-on-one tutoring. That doesn't scale. You can't do that with large classes. So what can we do? Well, it turns out that Benjamin Franklin, who is, I think, arguably the greatest scientist the United States has ever produced, his life project was to improve himself. This is what his life was about, how to improve himself. So at one point, he wanted to become a better writer. So what he did, he read a lot. What he did is when he saw something, he read something he thought was particularly good, he would put it aside. And then a few days later, he would try to write it down in his own words, paraphrase. And then he would compare what he wrote to the original. And he would notice the differences. So he used deliberate practice to help him learn what to focus on that he needed to improve. So here's what we can do. We can do the Benjamin Franklin approach, but we can scale it. Let me give an example. A learning objective: produce clear and cogent memos. So a memo is a short communication. Often they're over email these days. So first, instructors describe the characteristics of a good memo. You have to give them some information that they have to master. Then breakout groups write a memo, for example, to request funding for a speaker series. Then breakout groups receive an example of a good memo on another topic, so they can't just copy it, and note its characteristics. So they have to process it and identify ways to improve their own memo. So that's deep, deliberate practice 1. Then breakout groups revise their memos. And now here's something interesting. We now pair breakout groups. We have 2 groups we bring together, and we give them a rubric. And we say, okay, you've improved your memo. Now grade each other. Use peer grading with a rubric. So here's an example of what I mean by a rubric. So a good memo, if you look on the right, number 4, a good memo has all of the following: clearly stated reason for the memo, concrete specific language, all the necessary information, no extraneous information, based on logic, not emotion. If they had all those, they get a 4. But if they have none of those, they get a 0. If they have only one, any one, they get a 1. 2, only 2, any 2, they get a 2, so forth. So we give them the rubric, they come together, they use it to grade each other. So this helps them to focus on what they need to practice more on, deliberate practice. So a challenge, using deliberate practice at scale. A solution, use models like Benjamin Franklin's article he thought was well written, or we give you a model, and rubrics via peer feedback. So we can use deliberate practice at scale with hundreds of students at the same time. We break them into small groups, and we pair the groups. Okay, third of these principles that fall under this first big umbrella of pay attention, think it through. Dual coding. Learning is more effective when material is presented as both words and images. So telling and showing. So showing and telling. So here you have a mind map showing you what a mind map is. So it's using both the words and the spatial and color coding to help you understand what a mind map is. Any graph that's well done will be the same thing. A principle of dual coding, asking learners to produce mind maps, also has the added benefit of drawing on the principle of deep processing. So focused deep processing. Dual coding should lead learners to process deeply 2 different types of information, which are actually stored in different parts of the brain, by the way. So later on, you have 2 shots, 2 ways to remember it. So this works even when you supply your own images. So let's do another demo. You ready? Here's what we're going to do. Read each pair of words. You're now going to see pairs. If you see visualize in red in front of a pair, please visualize the 2 named objects interacting in some way. So for example, if you saw a cow tree, you might imagine a cow rubbing against a tree. Close your eyes, visualize. If you see say in front of a pair, please silently say the 2 words to yourself 3 times. So any questions about what to do? Let's try these examples. So what would you do with visualize chair shoe? Okay, what would you do for say window clock? So here's some examples. So if you saw chair, shoe, visualize, you'd visualize a shoe on a chair maybe. Say window clock, you repeat silently window clock, window clock, window clock 3 times. If you say rug moon, repeat 3 times. Visualize lemon fish, maybe visualize a fish eating a lemon or lemon squeezing on a fish or some way they're interacting. Okay, are you all clear what to do? All right, please do the indicated task for each pair of words in the following list. Do these tasks silently. Please don't write anything down. And raise your hand, please, when you're done with the whole list, please. Let's take just another couple of minutes. Okay, why don't we move on? Okay, now look at each word and try to recall the other word in the pair. You knew this was coming. So try to remember, go through each of them, try to remember what the other word was that was paired with it. Okay, now look at the words and count how many you recalled that you visualized and how many you recalled that you said to yourself. So score yourself again, please. Okay, here is the question. Did you recall more words following visualizing or saying the words silently? Could you raise your hand if you recall more words following visualizing? Okay, could you please look around the room? Okay, excellent. You are wonderful. How many recall more words saying them over and over again than visualizing? 1. Okay, interesting. All right. Its typical result is almost everyone recalls more words after they visualize them. Why? Visualizing named objects leads to 2 types of memories, visual and verbal. So one of the neuroimaging studies I did in fMRI is we had people visualize objects with their eyes closed and see them, not at the same time. One condition seen when visualizing. 92% of the same brain areas were activated with your eyes closed, visualizing, as with your eyes open looking. So when you visualize something, you are in some way seeing it with the mind's eye. So visualizing named objects leads to 2 types of memories, visual and verbal, which are stored in different brain areas, giving you 2 shots to recall them. And of course, there's more deep processing also, which is an added bonus here. Okay, so there were 3 principles under the first big umbrella idea. Pay attention and think it through. I'm sorry, it's very, very late in the evening for me. It's almost 2 in the morning, and I'm having memory problems now. Could someone remind me what were the 3 principles? What was the first one? What was it? Deep processing, yes. And what is deep processing? What is it? What? What is it? What is deep processing? The more mental, go ahead, you got it. What is it? Okay, the more processing you perform, the more likely to remember it, even if you don't particularly want to. All right, that was one principle. What was the second one? Deliberate practice. Okay, what's that about? Using feedback to identify the most difficult parts and focusing in on those. And what was the third principle we just did? What was it? And what's that about? Right, showing and telling. 2 ways. Okay, active learning. So one of the things you can do is you can ask people to pair up. I didn't want to take the time and have each person explain to the other person what they were. It's surprising how hard this is. You think when you're sitting and listening that you're understanding, and you are. You're understanding, you're comprehending, but you're not remembering unless you process deeply. And it's an illusion. There's an illusion that comprehension means learning. It doesn't. It doesn't. You have to process deeply. Okay, next category. Create appropriate mental connections. So the 3 principles just discussed form a cluster. They all rely on paying attention to and thinking through information. Following 2 are different. They rely on creating and using mental connections. All right, we're going to talk about chunking and building associations. Let's talk about chunking. All right, another demo. You will soon see a series of letters. Please try to memorize each letter in order. Ready? Now I'm telling you, you're going to memorize. How many letters can you recall? Anybody here recall 9 letters or more? Anybody? Yeah, you did? Did you notice the groupings? Correct. Okay, now everybody, you got it. Look for 3-letter acronyms, little shorthand abbreviations of famous organizations. Are you ready? Now look for them. 3-letter acronyms, famous organizations. Now, how many letters can you recall? Not a problem, right? You notice the groupings. So here, I'm using what's called bottom-up processing. That is physical characteristics to organize them. So you can see, because of proximity and similarity, but you just did it top-down by using your knowledge to organize them. These units are called chunks. The principle of chunking. Learning is easier when material is organized into 3 or 4 organized units, which are called chunks, organized units. Each of which, here's the trick, each of which can itself can contain 3 or 4 units. It can be hierarchical. So how do you define what a chunk is? You can use so-called Gestalt laws of organization, perceptual grouping laws, to organize material into 4 or fewer chunks. So I call this the birds of a feather rule. Here, there's 4 really important ones. Here are the 2 most important. Similarity. If you look on the top, you see 2 groups. You see the black X's and the red O's, 2 groups. On the bottom, same number of X's and O's, but now you see 4 because of similarity, how they're arranged. Below that, proximity, you see 2 groups. You don't see 8 separate X's. You see 2 groups, under that 4 groups, just by proximity, what's near to what. This principle, the birds of a feather rule, isn't just about X's and O's. It works with anything. It even works with birds. So you see similarity, there's 2 groups based on shape, color, and below that proximity, you see 2 groups versus 3 groups based on proximity. The real power of these organizational principles is that they're hierarchical. So here's a graphic showing you the Boston Symphony Orchestra, who plays what instrument. When you first look at it, you see three big wedges. You see a wedge here, in the lower left, a wedge in the lower right, and one on the top. That's the first level, 3 units. Then within the units, look what they've done. These are the first violins, second violins, proximity. So there's open space here. So you have 2 groups. Look over here. You have similarity of the double basses, the size and shape and orientation, violas, and so forth. Up in the middle, we're using symmetry, which is another one of these rules for the woodwinds, and then good continuation in a row up there. So these Gestalt principles, these principles allow you to organize things so an immense amount of information can be organized in a way you can take in. Chunking is not just for visual materials. For example, in one study, the participant learned to memorize 79 random digits presented 1 per second by organizing them hierarchically. Here's what they did. This was done at Carnegie Mellon by Bill Chase and Anders Ericsson and Steve Floon. They brought in a participant and they said, we'd like you to be in a study for a year and a half. Year and a half. We'd like you to come into the lab at least 3 days a week and sit and listen to us read you random digits 1 a second and repeat them back. First day, he sits down, they read him a random digit, 6. He repeats it back, 6, no problem. They then give him a list with 2, 3, 4, say. 3, 4, no problem. Then 3, 9, 1, 6. Repeats it back. Keep adding more. He gets 7 correct the first day. They bring him back next day, next day, next day. At the end of a year and a half, 79 random digits, 1 per second. How did he do this? He was a long distance runner, a marathon runner. What he did, he translated the digits into times, like 14.36 seconds. So 1436. He organized them into a chunk for a particular segment of a race they remembered. And he built a hierarchy of a race with different segments, organized into no more than 3 or 4 at each level. The very last day, they switched him to letters. You know how many letters he could remember, random letters? What's your guess? 7. The strategy for chunking worked for digits, not for letters. So chunking also applies to concepts. So think it through and create connections. I've chunked the 5 principles into 2. So one of the big reasons you want to do this, to chunk, is to minimize cognitive load. You want to minimize cognitive load by never requiring learners to process more than 4 chunks. More than that exceeds working memory, how much you can hold in mind. And they won't be able to do anything with the information if it's more than that. And you can use the perceptual grouping laws to organize material into new higher order chunk. So here's one way to chunk lesson plans. So a big problem with active learning, where you put them into small groups and they debate, role play, solve problems, many, many different things they can do. It takes time. So if you have a lecture that doesn't have active learning in it, how do you make room? So here's what you can do. You can imagine writing a transcript, write down your lecture. Then look at your exams. Each question in your exam, let's say you just have 2 exams, a midterm and a final. Look at where the information needed to answer that question was located in the lecture. Okay? So you'll group into conceptual chunks via similarity in the content about that question and proximity in time. So proximity works for time, not just space, nearness and time. So you can go through and you can chunk a lecture into the components that you thought were important enough to ask a question about. What about everything else? Well, if you didn't think it was important enough to ask about, maybe you don't need it. Maybe you can take that out and insert active learning exercises where they'll actually learn it. Instead of retaining 10% or so a month later, they'll retain more like 70%. So here's a way to think about this. I call it the learning sandwich. So there's 2 types. There's a front-loaded learning sandwich, where the instructor gives a brief lecture that addresses a specific learning objective. So I talked about dual coding, and then I showed you some examples. But that, to do it right, I would have had you engage in active learning, which is, in this case I did. I had you do the imagery example, and then debrief, tell you what it was, the point was. So you give them some information at the beginning, you then have them do active learning so they actually learn that information, and then you debrief, where you give feedback to make sure they're incentivized to do the exercise. That's front-loaded. The information content is at the beginning. You can also do back-loaded. So are you familiar with Eric Mazur's pure instruction method? Anybody here ever heard of that? Let me give you an example. He's a physicist. So he was teaching a course on kinetics. And he starts with a puzzle. In this case, here's what it is. You have a sheet of iron, 1 meter by 1 meter. You cut out a circle, say 1/4 of a meter, whatever. Now we have a hole in the center, okay? Sheet of iron, hole in the center. We now heat it up uniformly so it is red hot, okay? Not melting, red hot. Here's the question. That hole in the center, after you heat it up, will it get smaller? Will it stay the same size? Or will it get larger? So he gives the example, then he uses clickers to have people vote on the theory. You can also just ask them to raise their hands. So let me ask you, how many of you think that after you heat it up uniformly, that hole will get smaller? Okay? How many think it will stay the same size? How many think it'll get larger? How many have no idea? Okay, so starts off with a puzzle. People then vote. They then go into breakout groups and discuss it. Here's what's interesting. He has a vote at the beginning, and then after the breakout groups, vote again. More people get it right after, even if no one got it right to begin with. So the teaching assistants, if he does it in a room, you can do this online too, will listen to what they're saying in the discussion. They walk around, listen, and they'll give hints. So an important hint was uniform heating. So people often have the intuition that if you heat up a metal, the molecules will get more energy, more kinetic energy, and push against each other. So it'll expand, right? People have that intuition. But some people think the 4 quadrants will expand and push inward. Here's why it's important it's uniform. The molecules right around the rim have the same energy as all the other. They're pushing out. You'd have more energy to push them, to overcome that and push them in. You don't have it. So the whole thing expands out. It relaxes. It expands out. So it gets bigger. The whole gets bigger. So this is an example of a backloaded learning sandwich. You introduce a problem or an issue. The learners engage in active learning. They work to solve the problem or frame or understand the issue. And then the class as a whole debriefs. And the instructor reveals the answer to the problem, best way to frame, understand the issue. So you can do this with a demonstration, like deep processing, where I have you judging, and I'll tell you why. And you're wondering, why am I doing this? You see there's a difference, and then I reveal. So you can do learning sandwiches, front and back. So a typical class that we design is a stack of learning sandwiches. So this is 90 minutes of an actual class. So learning sandwich 1's backloaded. So the intro would frame a problem plus a poll, and then a single-phase breakout group where they're discussing it, and then debrief and a poll with a lecture, reveal at the end. And then another learning sandwich. This is with front-loaded now, not backloaded. There's a lecture or a video, the information transmission part, 2-phase jigsaw, just like the debate. There was multiple groups with, again, a debrief, question answer, and so forth. And we always have a question answer at the very end, and often a quiz, which is formative, just to give them feedback. Why? Deliberate practice. Give them feedback. Finally, last principle, building associations. Okay, here's a study. This is just a small part of one of the stimuli. The procedure is actually quite simple. So the participants are told to memorize this. The procedure is actually quite simple. First, you arrange things into different groups. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you are pretty well set. It is important not to overdo any particular endeavor. That is, it is better to do too few things at once than too many. In the short run, this may not seem important, but complications from doing too many can easily arise. A mistake can be expensive as well. Okay, half the subjects, the participants, were told this is about washing clothes. They were told that at the very beginning, about washing clothes. The others were not. You can guess what happened. The people who were told it was about washing clothes understood, recalled about twice as much as the others. Remember correctly, it's about twice as much. Why? Because you know about washing clothes. And remember, a lot of learning is about integrating what's coming into what you already know. So as soon as you can identify what's relevant, you can do that integration much easier. So uses of associations in learning and memory, there are three big uses. Organizing during encoding. Encoding is the first step of learning. You organize. So you use associations in chunking. I gave you an example. When you use top-down, IBM, CBS, that associations you already have of those letters, IBM, you already have stored in memory to organize what you're seeing. Second, storing information effectively by integrating it, prior knowledge. So washing clothes, a good example. The last use, which I haven't talked about, is retrieving information effectively by associating good retrieval cues. So a retrieval cue is like a hint that helps you remember something. So different contexts provide different retrieval cues. Here's one of my favorite studies in cognitive psychology. Here's what they did. Participants learned words either sitting on the shore or while in scuba gear 20 feet underwater. So half learn one way, half the other. Then you test their memory for the words either on land, on the shore, or underwater. So it's a 2-by-2 table. Half of them learn the words on land, learn the words underwater, and then half of each of those groups gets tested on land or underwater. Participants recalled about 50% more words when they learned and recalled the words in the same situation, either both on land or both underwater. Switching contexts between learning and memory, learning and testing, resulted in much poor recall. So this is a good reason not to listen to music when you study, unless there'll be music when you're taking the test. You want to avoid this situation where you can recall effectively only when in the original context. So you can do this by varying the context using different types of active learning exercises like role-playing, debates, problem-solving, evaluations, perspective shifts. I wrote a little book where I have dozens and dozens of different types of active learning as the last chapter. Just go through them, explain how you can do them both synchronously, either live or online, or asynchronously using a learning management system. There are many, many different types of active learning. And by using them, you have different contexts. And the more that different types you use, the more likely it is they'll have different retrieval cues. You can also use spaced practice. That is, you do a little bit spaced over time. Every time you would study, you're in a different context, maybe a different place, but certainly different thinking, different context cognitively, which helps you later remember. Okay, so the second set of two principles were chunking. What was that again? What's chunking? How many units? 3 or 4, right, and they can be hierarchically organized. So each of those units itself can have 3 or 4. And then building associations. So the really crucial thing with that is to integrate it into what you already know in a way that you can later be able to get it out by having good retrieval cues, so varied context. So science of learning, an enormous amount is now known about how learning, that is encoding and storage, so encoding, organizing, like with the IBM and all that, storage, like washing clothes, and memory, which is retention, holding on to it over time, and retrieval cues work, but very little of that knowledge is systematically used in education, especially online education. But it can be. It absolutely can be. So, science of learning, 5 principles, I organize them in 2 big chunks. I thank you.
예, 스티븐 코슬린 교수님의 강연을 잘 들었습니다. 굉장히 그 인지과학 혹은 학습과학에 기반하여서 사람들을 어떻게 학습하는지에 대해서 굉장히 친절하게 설명해 주시고 또 많은 여기 계신 분들에게 도움이 되었을 것 같은데요. 이제 Q&A 시간을 가지도록 하겠습니다. 네, 혹시 그 코슬린 교수님에게 질문이 있으시면 손을 들고 질문을 해주시면 좋겠습니다. 영어로 질문을 해주셔도 괜찮고요. 한국말로 질문을 하시면 저기 통역을 옆에서 해주도록 하겠습니다. Professor Koslin, we will have a Q&A time now. Someone can ask you question in English, or others can ask in Korean. Then there is a translator. He will translate the question to you.
Thank you.
Okay. Yeah.
Hi, Professor. I just want to throw some big questions. What are the biggest challenges facing higher education, and what do you think universities should do in these situations?
So I think a very large challenge facing higher education, talked about at lunch, is the shift from thinking about teaching to thinking about learning. So I've been talking about learning, where the first step is comprehension. You have to process deeply, and then all the other things follow. In order to shift to learning, active learning, very good way to do it. Lots of evidence, not my opinion, lots and lots of evidence. But it's different. Most faculty teach the way they were taught, and they were taught with lectures, where you just write down what was said as a student, memorize it, take a test. So the shift from that tradition to something new is going to be difficult. Good question. Thank you.
Okay. Hi. 엄성훈 교수님. 예, 질문.
Thank you very much for your lecture. It was very interesting and helpful for me. And I'm an assistant professor at the Department of Ethics Education here. And I'm having a hard time helping students to be autonomous thinkers, which is a bit different from being an active learner. Because what you showed us just now, it would be very effective in helping them to digest what we prepare for them. Just like, for example, in ethics class, like describe what Kant said about categorical imperatives, something like that. But what I'm being frustrated is to help them to think in a more free way. So like, there's no fixed answer. Perhaps there might be better answers, but I want them to be more autonomous and creative in giving a shot on their own opinions. But they try to see what's the correct answer to the question that professor is asking. So I'm wondering whether you have any effective way to lead them.
Excellent, really good question. So the first step is always about the learning objectives. And I advise clarity to make sure that the students know what the learning objective actually is. So if the learning objective is to help them think more creatively, that should be clear to them that they're not going to be graded on whether it's the right answer or not. That's one. Two, use of small breakout groups, much better than a larger group, because people get shy. You saw when I was asking people, I'm sure you all understood those principles, but people don't like in a large group to be vulnerable. Maybe they look bad, not good. So have small groups where they're clear what they're supposed to do, and have a group project. So it's not just based on one individual. A group project's a distributed responsibility and credit so that everyone feels they're participating and don't want to let each other down and will help. To the extent they start getting used to that, getting relaxed, I think you'll find improvement.
그 질문을 하실 때는 마스크를 벗고 말씀해 주시면 좀 더 정확하게 질문을 할 수 있을 것 같습니다. 예, 제일 뒤에 지금 마이크 가지고 계신 교수님.
Thanks for your lecture. I'm trying to apply your goal focused, as you mentioned in the earlier of the lecture. The goal, we have a particular goal to make 1% top entrepreneurial learning school program, something like that. And where I am currently located. And by applying active learning approach, what would you advise to make specific entrepreneurship focused? And there are so many programs in the world, and then
Right.
we want to make specific program for Seoul National University students.
Excellent question.
So
So the single hardest problem in the science of learning, single hardest problem is called the problem of transfer. Transfer. What students learn in class, they may not automatically use in the real world. They don't transfer from class to the real world. So it's very, very surprising. Students learn what they're taught very narrowly. So, let's see an example. So there was a class taught at Harvard, example, on physics, another physics class for non-majors, introductory physics for people who are not physicists. And the professor decided that they had to have a lot of examples, lots and lots of examples. So he used baseball. There's a lot of physics in baseball, Newton's third law, hitting the ball and all that. And he used so many examples from baseball in his lectures in the class that when the final exam came, he couldn't think of any more baseball examples. So he used examples from football. The students hated it. They complained. It just wasn't fair. The entire class was about baseball. And for the final, he tricked them by switching it to football. This is called a failure of transfer. Even though they're very similar, the underlying principles, very similar. So if I were going to be designing a school for entrepreneurship, I would think about active learning where I take into account the fact that the more similar the active learning exercise is to what you want them to do with that information in the real world, the better they're going to learn it and be able to use it. So I would be using role playing, where you assign roles and they have to do some entrepreneur-related problem together. And I'd give a lot of different problems, maybe based on different case studies. But I'd use other forms of active learning, all based on the sorts of things they actually have to do in the real world. So that's how transfer works. You have to do it as similar as possible. You have to give examples that cover the space and explain the principles. So to solve transfer. So I would use the science of learning to think about how to actually help the entrepreneurs learn what they need to know to succeed in the real world.
예, 다음 질문 받도록 하겠습니다. 예, 신정철 교수님.
Thank you very much. My name is Jung Cheol-shin, professor at the Department of Education. First of all, I would thanks to bring heavy rain today because we are suffering for water shortage quite a long time. And my question is when you start your lecture, you observed everybody here, and then you try to measure how much they are motivated, right? If I am not wrong. And then my question is, how you motivate your students when they are not much motivated to learn something from you. Second
Right.
question is, in contemporary higher education, most professors are research oriented, especially in my university. So that they are hired by research productivity. And then they are not much interested. Some of them are interested in teaching, but they are not much interested in research. In the case, how would you recruit your faculty members at Mineruba School, and how you promote them? And then how you teach them to apply your active learning principles.
All right. So
Practice.
for two big questions. So let me do the first one. Motivation. So a lot is known about motivation now. There are two big categories. They're called intrinsic and extrinsic. So intrinsic motivation, we're all born with. We don't have to learn. It's all coming from within. Three big factors. One is autonomy. People like having choice. Two is competence. They like to feel they've succeeded at something. Three, social relatedness. I kept mentioning don't let down other people, be motivated. That's where that was coming from. So you can take advantage of those intrinsic motivations in terms of how you design active learning. The three-phase debate preparation, the whole idea was for the focused processing to motivate them by the next thing that was going to happen where they didn't want to look bad, social relatedness. So you can use intrinsic motivation. Extrinsic motivation is rewards and punishments. So you can reward is much more effective than punishment, by the way. So you can reward them for doing well. It doesn't have to be anything more than praise or even other students' appreciation, depending on exactly how you structure it. So you can combine intrinsic and extrinsic motivation, which is what we usually do. So there's, I wrote a little book on this, which has a chapter on this, which I'm just sort of talking about right now. So this is there's quite a bit known about how to do this, and you can use it, and we've done this, and it's quite effective. That's first. Second, incentive structure for faculty. Many faculty at universities like this are incentivized by their research, not by teaching. So first question, how do you get them to learn to teach effectively? It's recursive. You use the techniques to teach them the techniques. So you have workshops that are set up. We do this. My company actually does this as part of what it does to help faculty learn how to do active learning. So they do active learning to learn how to do it. So that's the first thing. The second thing, though, is the harder part, which is institutional structure has to change so that incentives change. There needs to be more balance. They have to understand that it's not just being liked by students. You want to be an effective teacher where the students actually learn more. True student-centered education is education where the students actually learn. So you should measure that and reward faculty when their students are in fact learning well. And that should count for at least some of what currently the research credits are for.
예, 다음 질문. 예, 말씀해 주시죠.
Thank you. Oh, yeah. Yeah.
Into the Minerva project,
Mm-hmm.
and how you try to apply these
Mm-hmm.
various principles and values to the
Right.
Minerva experiment. Please give us detailed and concrete examples. Thank you very much.
Sure. So at Minerva, I was working with 16 principles. It was too complicated. So there's a book called Building the Intentional University. I edited it with Ben Nelson, who was the founder of Minerva. So it was a progress report after 4 years of what we had learned. So I wrote or co-authored, I think, 8 of the chapters. One of them was on the science of learning. And at that time, 2016, I had 16 principles. So I figured out how to reorganize them into just 5, because I realized some were special cases of others, some overlapped. It wasn't very good when it initially. I iterated. And that's what we did at Minerva in general. We iterated. So we collected a lot of data. So for example, you have to be engaged and participate in order to really get the most out of active learning. So we recorded everything the students said when they were talking. And on the platform, on the top, there was a little thumbnail of each student's face and a color, red, green, yellow, indicating how much they had talked. So students who talked a lot were red, because you didn't want to call on them too much, they already talked enough. Students who had not talked very much were green. So the faculty instructor could see at a glance which students needed to be called on to engage them. Because students often start off shy, timid, but after they start participating, they get used to it, they get comfortable. So you have to help them at the beginning. After you come along, after a while, you stop using it because everybody's relaxed and starts doing it. So we used feedback based on actual performance to shape their performance the way we wanted it to be. Everyone participating, everyone engaged. That's an example.
예. 오케이.
There were 7.
7, all right. These
Yeah.
principles.
That's a separate thing. That it was really quite separate. So the global rotation was based on the idea we wanted students to be leaders that have an international perspective. So we wanted them to live in different places. So that's the kind of learning that happens incidentally from experience, called experiential learning in the different cities. That's different than the very structured learning objective-driven learning that we did in class. So what I've talked about here was learning objective-driven in class active learning. Experiential learning is also active learning and also can have learning objectives. They tend to be broader, much less precise. In class, we have hierarchical learning objectives. So an entire course, a description of it, will say how we expect the student to be transformed by taking the course. That's a very broad learning objective, how they would be transformed. Under that, we have course level learning objectives, usually 3 to 6, where just more specific, but fairly general. Each of those corresponds to a unit in the course, which may have 6 or 7 individual sessions. Each session has learning objectives. So they get increasingly granular. On top of that, you would have the program learning objectives, institutional learning objectives, where experiential learning now can come in to deal with those kinds of things. So they're complementary. So we design them to be complementary, but they're different.
예, 다음 질문. 예, 송진웅 교수님.
First of all, thank you very much for your mentioning about lots of physics cases from the Harvard. I'm the physics educator. Thank you. And also you mentioned about the context effect at the end of your presentation.
Yeah.
And that was my doctorate thesis topics.
Ah,
Anyway.
okay. You probably know more about it than I do.
What I'm concerned
you
is
do.
that lots of your principles and how can I say the things you have talked as an educational psychologist or psychologist is to the science educator or to physics educator.
Yeah.
What we are dealing with, the concept is much more complex that the psychologists, their task so it is not very easy for us to apply them to the classroom in teaching the physics problems. The other issue is that you talked about the contextual effect and the issue of transfer of learning. Yeah, that is very important. I do agree with you. But to me, nowadays, I'm more concerned about the cultural dependency of the thinking. You are talking about and advertising the active learning, which is very difficult, in fact, for the East Asian students who are very shy and very reluctant to express their opinions, particularly in front of their peer group and in front of teachers. So what, do you have some kind of
Okay, so two
suggestion
questions.
for that? Yeah.
Two questions. First question is, what do you do with a really complex topic like physics? The answer is divide and conquer. You have to break it up into small parts with very clear learning objectives. So I gave you an example with the whole kinetics. So you can break down, in fact, there's a concept inventory, you must know this. There's the physics concept inventory where people have done this already. They've broken physics and chemistry and some biology into very specific learning objectives so that you can do exactly this. So that's not a problem. That's not a problem. The second part is a very important point, which is something we face all the time, which is initially people are shy. It's scary to be involved, to be engaged. So part of what you can do is small groups with anonymity, so they're not being graded, and the group as a whole is producing a work product, not the individual. So they don't feel individually on the spot, individually responsible in the way that they're worried about failing. So you can start off with things that are relatively easy. So go back to the intrinsic motivation. Okay, autonomy, competence, social relatedness. So you want to start with things that are relatively easy so that they can do them and feel competent, and then scaffold on that, build on top of that to build up to get more difficult. If you do that in small groups with group projects and you use some other techniques to get them engaged, which depend on technology, which you can talk about, it takes a while. It's like boiling a frog in a way. You know, you have to do it slowly. If you have the water boiling and you put the frog in, it jumps out. But if you put the frog in cold water and then turn up the heat, slowly heat it, the frog just goes to sleep. Yeah. Sorry, but that's a bad metaphor, but you understand. You know, I hope I'm getting clear. Yeah. Okay. Thank you.
이 자리에 이제 학생들도 좀 많이 참여를 한 것 같은데 학생들 질문 먼저 좀 몇 가지 받고 넘어가도록 하겠습니다. 예, 그 신부경 학생 먼저 질문을 하면 좋을 것 같은데요.
Thank you so much for your lecture. I'm actually a huge fan, and I'm one of those shy undergraduate students. So it's taking me a lot of courage to actually ask this question. So I actually have a brief question for you related to the Minerva experiment that you've taken a very big part of. So one of the aspects that I found really striking about the education is that it focuses on learning practical knowledge, which seems to be very much based on procedural memory. So for instance, like riding a bike and getting to know that it seems to take a very non-deliberate process to understand and formulate those memories. So I was wondering if, related to the principles that you mentioned today, is it possible to form procedural memories as well through deliberate and induced active learning processes? Yeah. And if so, how can teachers draw attention to the aspects of such procedures that need to be focused on in order for these learning to occur?
That's a great question. So if you think about a golf coach or any kind of sports coach, that's exactly what they're doing. They're working on procedural memories. And similarly, when you think about writing, an awful lot of writing is procedural. So what Benjamin Franklin did of comparing the really well-written piece with what he wrote, he was building on his procedural memory. But you need to do it over and over again in different contexts. Speaking of, I need to clarify something. When I made the frog metaphor, I just want to be really, really clear. The students were not frogs, okay? The metaphor, that was, it's very late in the evening for me. No, I'm not comparing, no. The idea is that if you do things gradually and start with things that they can succeed at. This works for procedural also. And then build on that, they will succeed. If you start immediately with something very hard, you'll have trouble. If you immediately ask them all to participate, and so it's not going to work well. So I just want to be clear, that metaphor, nothing to do with students, okay, in terms of frogs. No. Okay, but yes, the answer is you can use exactly the same principles for procedural learning. Deliberate practice is probably one of the most applicable, but so are the others. They all actually work. All of them do. Great question. Thank you.
학생분들 중에 제일 뒤에 그 남학생.
Do you hear me? Can you hear me? Okay. I have a question. Thankful for your wonderful and insightful talk. I'm Daniel Ko, who is majored in data science and teaching English as a teacher. So my question is about the relation between active learning and data science or AI. I think these days we are witnessing a kind of newly emerging era. About 6 years ago, very famous Go player Isidore Gudan was defeated by AlphaGo Google DeepMind by 4-1. And so after that, a lot of people in South Korea became more interested in data science or AI. So against this backdrop, what do you think of the role of active learning in such environments, and what should we do for our future generation to use those kind of five or more principles for learning more about in the future world regarding data science or AI?
I'm not quite sure I understand the question. So you want to know?
So I'm sorry. So what do you think? What do you think the main role of active learning against this backdrop under such circumstances which AI is prevalent and data science is prevalent, and the other thing is in this kind of educational transformation era, what is the thing we should keep in mind?
So active learning is very, very general. So in terms of if you want to teach students how to learn to do AI, is that what you're asking about? I'm still not sure I understand. I'm sorry. You can certainly use active learning to do that. But there's another way to look at things, which maybe is what you're driving out here. If you think about future of work, you can think about the kinds of things that AI can do well and the kinds of things that humans can do well. So the question is, what sorts of things would you want to focus on teaching humans that won't be easily automated, won't be easily replaced by AI? So I did an informal study where I looked at about 12 different professions, from bartender, barista, physician, lawyer, whatever. And I just sorted the things they did. I listed out what they did, which things would be easy to automate or already have been automated, and which things wouldn't be. And what was interesting was the things that were difficult to automate all involved either context, that is, taking context into account, because context changes, it's open-ended. Machine learning AI is based on past events. By definition, you use a lot of data collected it, past tense. Whereas what we do as humans is as soon as a new event occurs, we instantly can change our orientation and take into account the new context, determining what we do in a way that's very difficult to do for a machine. That's one. Second is emotion. We humans are very good at both using emotion to prioritize our goals and understand what we're doing, but also understand other people, understand their attitudes and the kinds of things they're communicating to us. Very difficult to automate. So if I were thinking about educating people in the age of AI, I would think about the kinds of things that would be difficult to automate and how best to work with AI. To use AI as kind of a prosthetic, a kind of extension of us that augments us, helps us, in addition to just what it does by itself. So I'm not sure I answered your question, but those are my general thoughts on AI, such as they are.
Thank you for your answering.
그 지금 온라인에도 질문이 몇 가지 올라오고 있는데요. 그 온라인에 있는 질문들을 대신해서 한두 가지만 질문을 하고 오늘 Q&A 시간을 좀 마무리를 해야 될 것 같습니다.
Here's some questions of the audience who participate through Zoom online. Yeah. Question is, how could you integrate the principles into the design of courses of the Mineral School? Were you able to intervene each of courses?
So how would you integrate?
How could you integrate the principles into the design of courses of the Mineral School?
Oh, how do we integrate these principles? Well,
Yeah.
we didn't, because they didn't exist then. So these 5 principles came, the book I published on this was 2020. So October 2020. So the book from Minerva was 2017. And these principles are different. I organized them differently. So the principles we had then, I had 16, way too many, not well thought through. I was still working on it. We integrated those by how we designed active learning. So we designed many, many exercises like the kind of thing like the debate. That kind of thing we did at Minerva, where we do a lot of jigsaw, where we'd have a series of homogeneous breakout groups, then break them up and reassemble them and do something, where sometimes they would specialize in different components and bring them together to solve a problem. So that was the original jigsaw idea. So we built that all into the technology. So it was very easy to do in the technology. So one of the things we did at Minerva that I thought was one of the best things we did was we built a technology to facilitate active learning. So when we would come up with new ways to do active learning, we'd make it easy to do. That was a really great thing. Still is a great thing about what they do.
온라인에 질문 하나만 더 마지막으로 하면 어떨까요?
Yeah. Second question is, what myself as a reliable indicator or assessment tool of how well students accomplish an active learning objective?
So how do you assess active learning?
Yeah, indicator or assessment
Yeah.
tool.
So you need clear learning objectives. So you always start with the specific objective of what you want them to learn. So it depends on what the objective is as to how you measure it. So if it's something like describe RNA and DNA, it's easy. You just measure whether they can describe it or not. But there are many different analyze, synthesize, explain. So depending on what the verb is, that's part of the learning objective, you measure different things. Sometimes it can be easy to measure with just a test. Sometimes it would require an essay or something like that. Sometimes it might require looking at a simulation and predicting what will happen next. It depends on the learning objective.
Thank you very much.
Surely.
시간이 이제 3시 반이 거의 다 돼서
Very
여기서
good
좀
questions.
마무리를 해야 될 것 같은데요. I really appreciate your presentation, your lecture, and Q&A time. Please give him a big hand. Thank you very much.
Thank you. Thank you very much.